Integers. Just some basic rules that you learned either last year or even the year before that. A lot of us did this in 5th grade. The basic idea is a positive times a positive is going to equal a positive. These are just your basic multiplying integer rules. Positive times a positive equals a positive. A negative times a negative equals a positive. That's one that throws people off. A negative times a positive equals a negative, and a positive times a negative equals a negative. Essentially what it's saying is if you're multiplying two integers and your signs are the same, your answer is positive. If you're multiplying two integers and your signs are different, then your answer is going to be negative. We're going to use those rules to kind of help us look at some examples. For example, if I have negative 4 times 3, first thing I'm going to do is figure out, is my answer going to be negative or positive? I'm multiplying a negative times a positive, so is my answer going to be negative or positive, class? Negative. Excellent. So my answer is going to be negative, and then I'm going to do 4 times 3. What's 4 times 3? 12. Very good. So there's your answer. But like everything we do in math, it doesn't stay easy for very long. Let's look at negative 4 times 5 times negative 3. Now we're going to do this just like we did order of operations a couple weeks ago. We're going to simplify left to right order of operations. So we've got multiplication, multiplication. We'll do negative 4 times 5 first. What's going to be negative 4 times 5? Negative 20. It's going to be negative because a negative times a positive gives us a negative. So we did that and got negative 20. Now we have to carry down the negative 3. Negative times a negative, is our answer going to be positive or negative? It's going to be positive. 20 times 3 gives us 60. So your answer there is a positive 60. What if I have something like negative 3 times negative 1 times negative 5. In that example, is my final answer going to be positive or negative? Now I hear people say right away it's going to be negative or positive. If you said negative and you said it quickly, how do you know just by looking at it if it's going to be positive or negative? Alexis?
Because you're gonna take you're gonna simplify it. So you're gonna do negative 3 times negative 1, and you do it like this, it's gonna be positive.
Mm-hmm. So you just really quickly in your head just figured out, well, that's going to be a positive, and then a positive times that'll be a negative. You just figured it out really quickly, right? All right, so if I have negative 3 times negative 1, that gives me 3, because it's negative times negative is a positive, and then I'm going to multiply that times negative 5. Positive times a negative will give me a negative. 3 times 5 gives me 15. It seems like there's a pattern here if my answer is going to be positive or if my answer is going to be negative. What if I have something like this? Let's have negative 2 to the 3rd power. Is my answer going to be negative or positive? I heard people.
Positive. Negative. It's positive because it's multiplying. Oh wait, multiplying two. Positive.
Let's re-examine what this actually means. This says I'm going to take -2 and multiply it times itself that many times. So I'm going to take -2 and then I'm going to multiply it times -2. Then I'm going to multiply it times -2. So when I do that, it'll be a negative times a negative gives me a +4 times a -2. So my answer here is a -8. So what if I have -2 to the, I don't know, let's say 4th power? Is that going to be positive or negative?
Positive.
If I have, so you're saying that the answer to that will be positive. What if,
Positive, so.
what if I have -2 to the 7th power? Negative or positive?
Negative.
Negative? What if I have -2 to the 14th power?
Positive.
Now, how are people figuring that out so quickly? Because they're not going to do -2 to the 14th power in their head and just know the answer. Stuart, what are they doing?
Keep it numbers and positive or even extra positive number and odd exponents would equal negative.
So what she's saying is that the even number is positive, the odd number is negative. That's what you're saying, Haley? So what she's saying here is if I have a negative times a negative, it'll equal a positive. If I have a negative times a negative times a negative, that'll be negative. If I have a negative times a negative times a negative times a negative, that'll be a positive. If I have a negative times a negative times a negative times a negative times a negative, that'll be a negative. And what you're finding there is that every time you have an even number of negatives, your answer is positive. But when you have an odd number of negatives, your answer is negative. So we can use that when we have those exponents. Excellent. Very good. That's an important pattern to recognize. Now, there's really only 2 more examples that I want to look at. The first being 2n times -4. We're going to be looking at expressions that have variables in them where we're not given the solution. We don't know what the value of n is. What operation happens right there when there's a number and a letter next to each other, Julian? Yeah, that's the same as multiplication. The commutative property of multiplication says that the order of those numbers doesn't matter. This times this times this, order does not matter. So since I don't know what the value of this is, I'm going to set it off to the side and kind of set it at the end. So I'm going to do 2 times -4 times n. All I did was I rewrote the problem in a different order. But remember, order doesn't matter when they're all multiplied together. Now I can actually multiply those together. +2 times a -4 gives me -8. I still don't know what the value of n is, so I just leave it as an n. There's your answer. And it's weird for some of you. Some of you are looking at it and saying, there's an n in the answer, but I don't know what the n equals. What's the answer, Mr. Tom? That's not what we're doing here. We're just trying to simplify that, combining what we can combine. Let's see one more like that one. I have -4ab times -6. Try that example on your own. Use what you learned right above it. So we'll put the multiplication signs in there. Anybody think they got it? There we go. I'm going to rewrite this. She got the right answer. I'm just going to kind of rewrite this so we can all kind of see. What I did was I moved those variables to the end because I can't use them right away. I'm going to push them off to the end. Now I've got -4 times -6, and you said that was 24. So that gives us 24, and negative times negative gives us a positive, and the AB right there on the end.